we're looking for. We're looking for times where we come out to 0, and we know that is a factor, so therefore we can find a root. And if we keep on dividing, we will eventually get down to a quadratic type, a squaring function, and we can factor that. So sometimes we need a little bit of assistance. We need a little starting point. So I have this function. So let's put this in your calc and make a little sketch. You don't have this. All right. Let me start with the one you have. Let's start with the one you have. Now we need to factor this and get all our zeros. We put y equals 0 and we factor. Can we factor this? Can you take out an x, factor out an x? Oh, can we group this? No. So we need a little start. So we're going to put this in your calculator. We're going to sketch your graph. And we're going to see if we can find a 0. 1, 0. This will have how many zeros? 3 zeros. 3 real roots for this guy. 2 terms. Good. 1 inflection point. It's kind of like a pattern, right? Yes. Well, that's because Imani gave it back. That's okay. She forgives. Okay, so put this in your calculator. For some reason, I gave you the easier of these. So end behavior says down on the left, up on the right. So somewhere it looks like it's turning close to that axis, but I can't see where. Now, all I have to do is find 1, 0 in my table. Just 1, 0. So go to your table, and if you see if you can find me where there's 1, 0. 0, 0. Oh, I put the wrong thing in. That doesn't look like what you have. No, I put the wrong thing in. Sorry, I put the first one in. I'm saying no, it looks exactly like mine. So yours should look like this. Turns here. So Bram, absolutely right. 0, 0.
It's 0, 2.
It's 0, 2?
Okay.
Okay.
I changed my window, so
2? Alright. So now, we're going to start with this guy. So somewhere you found 1, 0. If you found the other one,
there's no 0. It goes up to the left, and then it comes like the min. The relative min is at
0, 2. Sorry.
Yeah,
But that's not what I want. Let's start this over again. Let's start this all over again. No, I know, but now I can't erase this. Let's just start this over. I'm sorry, guys. It throws me off when something goes wrong and you have the wrong sheets. So, let's small again. Alright, so let's start again. I want a 0. So your graph is looking like this. So we said we would see 3, right? I need to look in my table for y to be 0. That's still not what it looks like.
The minimum is at
Oh, I
0.
got a plus instead of a minus. I'm sorry. Okay, I'm going home. I'm gonna start my day over. I'm just gonna have to start my day all over. You're lucky because I was giving you a really hard one. So somewhere it goes like this. Oh, I didn't want to give you imaginary. All right, I didn't want the imaginary, but as I wanted to do the real zeros. Could we not do this? I don't want.
So much effort into it already.
I did. But I only want the real zeros.
Wait, so we're not doing
We're not doing that one. You do. You do have the wrong one. For some odd reason, I don't have this one for you. The roots. This has imaginary. Today I only wanted to hit the real
So
one.
we'll just write down.
So here, start like this for me. I want you to put this in. Let's just start our day all over again. I didn't want to hit the imaginaries till tomorrow. I just want to concentrate on the real roots today. I don't know why that this one's different than mine. Some odd reason. It must be written over in my stick there, so I have to figure out what happened to it. All right, so now, please put this in your calculator and graph it for me.
You want to write this one real fast?
Yeah. Whatever you have, cross it out. And let's write this one. I don't know why I don't have this one. Because it's password 4. I don't know what happened to it. So now, it should look like this. Are we all agreeing with me? Am I good? Okay. Now, I need to have a y of 0. There are 3 roots in this. 3 roots. I can solve something when it's a square. I can't solve it when it's a cube. I can't factor out. I could try grouping, but seems to me if I take out a 5 out of this, I can't take a 5 out of the second part, right? I'm not going to be able to be left with something because these are multiples of 5. I'm not going to be left with the same thing. So I won't be able to group that. So find me 1, 0. Where's there a 0 here? 2. Okay, this is why we learned synthetic division. Because we're going to be able to factor out this. Because it is a 0, when we synthetically divide this out, we should end up with that little 0 there, which tells me this, in fact, is a root of my equation. Once we get to a square, we should be able to factor. Adam?
No, it's just weird. Looks like it's trying
Oh,
to
it looks
stop
like
it, but
it's stuck. It looks like it's stuck. You know what, Ian? I can just clear it. Go ahead, you can open. I'll just clear it. Something must be stuck in there. All right, so let's start when we have a root of 2. Now, we don't say minus 2, we say 2 because this is in fact our root. Our factor would be x minus 2 because we've set it equal to 0 and 2 would be our root. This is where your root goes. So let's pull out your leading coefficients. 10, negative 15, negative 16, 12. And make sure you run it down. 3, 2, 1, 0. So we're going to drop the 10. And we're going to synthetically divide this out. So much easier than a long division. 2 times 10, 20. Add it down. What do you get? 5. Now what? 2 times 5, 10. Add it down. Negative 12. Ah, this in fact came out to be a 0. Yeah.
I didn't know which one's the remainder, like where the remainder was.
Because we're going to do this. If we divided this by x minus 2, because that was our factor, x2, 3 over x1 gives us x2. So pretend I didn't know that was the remainder. So this is 10x squared plus 5x minus 6x to the 0, right? So I got another piece over there. That's my remainder. Because this technically is my x0, my x1. So I kind of ran out of x's. So once I reach the end of my x's, that's my remainder. Now that last one, if I divide it by one root, I should have one place for remainder, one term. This tells me, yep, this was a root of your equation. Now, I'm to the point where I can factor this. Might not be pretty, but I can either try to factor it, I can do the a times c if it works, I can complete the square. So we've got negative 60. Do you have factors of 5 that add up to negative 60? No? So if we can't factor this, what can we use? Quadratic or complete the square. Which one would you guys like to use? Complete the square. So remember, if you're going to use complete the square, if you want, because you're solving for your roots, you can throw the 6 onto the other side. You don't need the vertex, you need the roots. So I have to factor out a 10, right? So I get x squared. If I divide this by 10, what do I get? 1/2 x plus something equals 6 plus something. Wait, say that again? Because you need your leading coefficient to be 1. You need your leading coefficient to be 1. I have to move it up here. So we're right here. Okay, what is my rule? I take half of b. So if I divide this by 2, what do I get? 1/4. So I get x plus 1/4 squared. And 1/4 squared is 1/16. I've got to multiply this. I'm not going to reduce it. I'm just going to leave it 10/16, because you're going to put this in your calc and get an answer. So in your calc, add 6 plus 10/16. It's not a pretty one to do like this. So when it works out, usually my rule of thumb is if my middle one is odd or less than my a, I'll usually use the quadratic, but you can use anything you like. So what do we got? 53/8. Okay, so now take the square root, so you get x. I took the 10 out. Okay, so we're going to have to divide, even messier. We have to divide this by 10, and then we're going to take the square root. You can divide this by 10 in your calculator. Not pretty. So is it 53/80? Then take the square root. So, and then subtract 1/4, so you get negative 1/4 plus or minus the square root of 53/80. Now, we don't have to reduce the radicals anymore. You can leave it like that. If this can be reduced in here, you can reduce it. If you do have a perfect square, you have to take it out of there. So you probably do have a perfect square in 80, so you're going to have to reduce that. But these are our other roots. So do we end up with 2 roots? So altogether we get 3. Now, a good way to check this is in your calculator. Keep your graph and go to value and just put in one of these. Just leave it like this without reducing it. When you do this, if this comes out to say y equals 0, because you don't want to put in a decimal, because if you reduce this to a decimal, it's not the exact value. If it comes out to be y equals 0, you know you found a root. The other one works because it's its conjugate. So see if that comes out okay. It's just a good way to check it. If one works, the other one works because they're a conjugate pair. And if you have to do a little reducing, do it before you reduce and make sure you got it right. So the reason we do synthetic division is to help us start finding factors, because we can't factor these things. And if we can find one to help us out, if this was an x to the fourth, we would need two of them to get to x squared. So what we would do is start here and do one again. Let me see if I have a homework one, and I can do one with you there. That has two roots. All right, this is a really good one. Everybody okay with this? Good? All right. Unfortunately, you don't have this either, so if you can write this down. You do use your calculator because you have to find a root. Hang on to that. I don't know where that is. That is my regular precalc unit 4. Because I do more with you guys. I don't know what happened to yours.
Why are we supposed to do this problem?
So how are we supposed to do this? Good question.
Where?
Oh, you're supposed to write this, just cross out something and write it down. Put it on a piece of paper anywhere. Okay, so now, graph this for me. Let's make a sketch. How many roots should we have to this? 4. Okay. So if I can factor from a square, that means how many zeros do I need to find? I can only factor when I get to a square, to quadratic. So I need to find 2 roots. Good. So put this in your y equals. You should have two zeros here at least. Yeah, but you should see at least 2 in your y equals table, in your y table. We're going to find the rest of them, but you should at least have 2 because we need 2 to get down to a square. So it's something that looks like a big W again. Something that's going like this. Coming up here somewhere, turning, and then going like this again, somewhere. So find me, I need to find 2 roots. I need 2 because once I get to a square, I can factor it. You got a 4, 0. And you have another one? -3, 0. So now, we're going to start synthetically dividing. I need to get down to a square. I can't factor this guy. I have no idea how to start factoring him. If I combine try to group, this isn't going to happen for me because there's nothing between 4 and 55 that would work out for the other part. So I'm kind of stuck with the try to grouping thing. So I'm going to factor out the -3. This is a root. What should this last thing come out to say? 0, because we know this is a root. It's in my table. That should come out to say 0. So let's pull out your coefficients. So what do I have? 4, 0, good. Good. And 36. Okay, so let's divide. We bring down the 4. -3 times 4, remember, multiply from the left, go to the right. -4 times 3, 12, I'm sorry, -12. Add it down. -3 times -12, 36. Add it down. You get -19. -3 times -19, 57. Add it down. What do you get? 12. -3 times 12? What did we get? 0. Yep, that was a root. Now, watch. I took one root away. So instead of starting with x to the 4th, this starts me with what? x to the third, because I took one x out of there, right? But x to the third, x squared, x, that still looks like a nightmare to factor. So therefore, yes,
For, like, I get how you got -3, but I thought you had to switch to positive first.
so when your factor looks like this, we set it equal to 0 because we need to find the 0. When you go to your table, x is equal to -3. That is done for us. So that's the difference. And that's a very good question. That is the root. This is a factor. If we were going to bring it backwards, we would have to remember set that equal to 0 and move it, and x plus 3 would be my factor. So we do find a root. Excuse me. So now, we do this again. We take out another root, and the other root we saw was 4. Yeah, we have to do it again. This is why you learn synthetic division. Now, doesn't matter which one you use first. Doesn't matter. But what should this guy come out to be down here? 0. Because we know that, in fact, this is a root. So therefore, if it doesn't come out to be 0, then we did something wrong. So this is a good way to remember that. So bring down the 4. 4 times 4 is 16. Add it down. 4. 4 times 4. This gives me a -3. Now, for instance, say I added that and I got a +3. When I multiplied this, that 12 and 12, it wouldn't give me 0. So I would say something went wrong. Go back and look. Oh, this was supposed to be a -12. Yep, and I get a 0. Now, I took away another root. I was x to the 4th. I went to x to the 3rd. If I take another x away, what am I at? X. So x squared. So this is my 4x squared plus 4x minus 3. From there, I either do the quadratic formula, I try to factor. Actually, this is factorable. I'll give you the factors so that you don't go crazy. You can do an a times c on this. Always check a times c to make sure factors of -12 that add up to 4. There's your 6 and -2, right? So I'll just give you the factors so that you can see where we go with this. It factors to 2x plus 3 times 2x minus 1. These are my factors, so don't I set my factors equal to 0? That's where my roots come from. So x is equal to -3/2, and x is equal to +1/2. So I have 4 x's, 4 roots in here. I have -3/2, +1/2, -3, +4. These are my zeros. And if I want, I can go back to my graph and I can check these values. I can see that I would do calc value, put in -3/2, make sure it comes back to a 0. The one thing you can't check is if you reduce something to a decimal and you round it, it's not going to come back to exactly 0, but it will come back pretty darn close. So this is the reason we do synthetic division. Usually what happens is you learn some of these steps in Algebra 2, but you don't really get to see why did I have to do all that. This is why we do all that. So does it make sense? Okay, now we're going to try a tough one. You have no time. Okay. All right, I'll tell you what. Instead, I hate to do this to you, but let me write down a couple that you can do for homework. Can you guys write these down and don't do the homework that you have? Here's the first root for this.
Is that a 4 or a y?
That's a y equals y. Or 0. You're going to put a 0 in here anyway. see. That's just a function. That one I'm not going to give you a root because you're going to go to your calculator. This one had all fractions, so I had to give you this one. Okay. That one you're going to go to your calculator too. That's a positive 2x to the 4th. That's my equal sign. This is why I hate negative numbers. They get mixed up with my equal sign. This is going to be the last one. Oops, hang on, this is wrong. My eraser doesn't work, believe it or not.
It doesn't?
No,
So she clears them.
that's why I have to clear everything, yeah.
You have
Watch, if I try to erase, it just moves it around. It doesn't do any of my erasing. I can move it, but it can't erase it. I don't know what's wrong with my board. Trying to work like me. Alright, so just these 4. If I don't give you a root, that means you have to go to your calculator. This root I gave you because you're not going to find it in your table because it's a fraction. I will warn you, this first one has all fractions, as 3 fractions as answers.